What I'm going to show you is the Lucas Nulle training equipment in professional photovoltaic systems. With increasing demand for renewable energy, the photovoltaic system has become an important source of electricity. Since the experiments must be conducted inside the laboratory and there is no sun, we have to think about an alternative. Therefore, we have developed a system which can emulate the behavior of the sun. I would like to start by briefly describing the components of our solution. As you can see, we have different hardware modules that represent the different components of the photovoltaic system. For the beginning of the learning process, we introduce the solar module rack, which consists of a monocrystalline solar module and a halogen spotlight as solar simulator. The brightness of the halogen spotlight can be adjusted using a dimmer. Various rooftop angles can be emulated using a tilt adjustment of the solar module, allowing it to be investigated. The halogen spotlight is adjustable, permitting it to emulate the progression of the sun over a whole day. To be able to emulate the position of the sun over the entire year, the elevation angle can be adjusted. We are going to move on to the grid-connected system. Here we have the connection point to the mains, accompanied by a smart meter, which transmits important information about measured parameters to SCADA. Next, we have the storage system terminal panel, which is used as a connection point of the load, the battery, and the solar generator. In the middle row, we find the most important element of the system, namely the industrial photovoltaic inverter. Some functions of this device will be shown later on during the experiments. The generated solar energy can be stored using the battery storage device and be used in case of peak consumption periods. Last but not least, we have the solar panel emulator, which consists of a controlled DC power supply and a software with a special control algorithm, ensuring that the current and voltage behave analogously to the photovoltaic module. This combination works like a real solar facility. Along with the system, you will find an interactive course that can be installed on a PC. The multimedia user-friendly platform used here is called LabSoft, and it consists of theory background, animations and wiring circuit diagrams, practical exercises, and real-time evaluation. Additionally, each course has different virtual instruments that will make the configuration of devices and data acquisition easier. Let's start with the first experiment. The objective is to make the characteristic curve of the photovoltaic module. Using the assembly instructions, I proceed to wire up our system. The virtual instruments of each course can be found on the corresponding menu in LabSoft. For this experiment, I am using the instrument XY plotter. The scaling must be adjusted according to the instructions. I am setting the irradiance to its maximum value, the potentiometer to 0 ohms, and start the recording. By slowly increasing the resistance value to its maximum, the characteristic curve can be captured. Reaching a better understanding of the basic concepts is possible through different experiments. After learning all the principles of photovoltaic modules, we will start investigating the grid-coupled solution. It was mentioned before that for emulating the behavior of a solar facility, we can use the solar panel emulator. Here you can see the graph of the emulator represents the real characteristics for voltage versus current and power, and is comparable to the previous experiment. You can see the options to increase and decrease the solar irradiance value. Solar radiation scale is from 0 to 100%, where 100% equals 1000 kW per meter squared. One can as well adjust the number of shaded modules and the shadow percentage. Additionally, you can create your own solar profile for a specific time period, or even import real data. I am going to present an experiment where the concept of MPP tracking is brought to an understanding. According to the experiment instructions, I will adjust the irradiance to 100%, 80% and 50%. The diagrams can be copied to the LabSoft course for evaluation. Here we observe that the operating point of the solar modules and generators is always maintained at the value from which the maximum power is delivered. In each experiment page, students must fill in the graphs, answer to the open field, multiple choice or single choice questions. The real-time evaluation will help the lab instructor to have an overview of the student's performance. In the next experiment, a supervision control and data acquisition of SCADA interface will be used for limiting the active power of the solar facility. According to the country-specific regulations for renewable energy sources, power reduction or derating should be available for reducing active power in order to avoid network overload. I am going to adjust the derating using the scale to the required value according to the table and then enter the measurements. You can directly see the diagram and use it to answer the questions correctly. These were some of the experiments which can be found on the LabSoft course for professional photovoltaic systems. However, you can see that the course covers much more detail and the students can acquire a very deep knowledge of this topic. Alongside this type of distributed energy resource, we also offer other training systems on wind power plant, photovoltaic systems, conventional power generation, smart grid distribution and cybersecurity, consumption and energy management, transmission and protection techniques, and many more topics. All combined can form a greater system, namely smart grid.